Hello, everybody. We're really thrilled today to have Chris Bregler for our as a distinction in our distinguished AI lecture series. For those that doesn't know Chris, Chris is currently a director and principal scientist at Google AI. He has received an Academy Award in the Oscar Science Technology category for his work in visual effects. He has done a lot of work on computer vision and computer graphics. And for me, I would like to say a little bit more personal things. Is Chris' paper, which is called Recovering Non-Origin 3D Shape from Image Streams, is one of the first papers I have read in computer vision and actually inspired me to do a PhD in the field. He will talk today about synthetic media, new opportunities and new challenges. And the floor is now to Chris.
All right, thank you so much for this personal introduction. Can you hear me? And you can see the slides. Okay. Well, since you did a personal intro, let me also continue in the personal thread. Well, I was also inspired a lot by what Stefano and his collaborators in his lab were doing the last 5 or beyond 5 years. But then also when I got my PhD at UC Berkeley, it was in computer vision with Jitendra Malik and Jerry Feldman and David Forsythe, and there was a lot of focus on object recognition and many other things than scene understanding. But I was sort of an outlier. I always wanted to do computer graphics, and my office mate was actually Paul Debevec. So we were these 2 outliers in this vision group trying to do visual effects and computer graphics. And then in the mid-90s, there was this movie called Forrest Gump came out. And I was mid or early 90s. I saw like, oh my God, how does John F. Kennedy or John Lennon or all those people so photorealistically talk to Forrest Gump? And I knew one of the people at Industrial Light and Magic, which is the visual effects house of Lucasfilm, just across the bay from Berkeley, J.P. Lewis. And he's sort of a partner of myself for the last 25 years. And he told me, yes, it was all in Photoshop. They went frame by frame. Artists were moving pixels around. They found all the footage, and it was done very smartly. And so I proposed then, I went actually to a company in Silicon Valley, Interval Research, and I proposed a system called Video Rewrite with colleagues there, where we can do this automatic. So we built up earlier in Berkeley all kinds of computer vision and machine learning techniques and speech recognition techniques. Machine learning was not very deep, but it had some neurons in it. So technically, maybe you can say it was sort of medium deep, but not very deep. And we built this thing, and we got from the National Archive the John F. Kennedy footage during the Cuban Missile Crisis. And we made John F. Kennedy with vision, speech, graphics, machine learning, say things that he never said before. For example, he said, I never met Forrest Gump. So just double check, you see my slides right now. What then kicked in gear is J.P. Lewis moved to Disney, and sort of this video rewrite system was sort of the early one where we take lots of 2D data and texture data and retarget that. And the philosophy was still, don't touch it up too much. As more you alter the data, as higher the chances that you fall in sort of the uncanny valley, that like a few pixels are wrong and the illusion is broken. But at Disney, back then, it was the secret lab, and then later feature animation was a new test going on for Gemini Man. And this sort of followed me for the last 20 years. And some people say the virtual Turing test, or some people, we can also say the Gemini test. Can you build from scratch an actor or actress, a hero? Like hero means not just like a few pixels in the background, but full, like back then it was HD or 2K, now it's 4K or 8K, and synthesize that, and you cannot tell the difference between a real actor and a synthesized one. So we kicked this off, a huge team at Disney. Here are all the collaborators, and it was led by Lance Williams, the Digital Human Project, and for several years worked on this, and it's sort of done in the traditional way, 3D scanning, texture modeling, blend shape modeling, and many other things. And then we sort of had this thing called Visual Servo, and nowadays you would call it a differential renderer. And for many, many years, I like to claim this technique was sort of state of the art. It sort of moved on when I was at Industrial Light and Magic, and we compared it. It was still very much state of the art many years later. But the first test here, how far are we into this Gemini test or Turing test, is can you just reproduce the actor itself? And so I think in 2002, the group passed that test. Now, I think you should see this moving right now if my slides are presenting. But then the next step is the movie script of Gemini Man back then, and even when it was released right before the pandemic, that was like already 2 years ago, is like somebody gets cloned into a younger version, and then that younger version tries to kill the older version. And back then, the younger version looked like that, and that did not pass the Turing test yet, the visual Turing test. You see here, it sort of looks okay, but it's too shiny. Subsurface scattering was not applied. Something wrong with the eyes, a little bit unnatural. It was still in the uncanny valley. And so Disney back then decided to not go ahead with the feature film. The entire group was disbanded. People moved on. And many of us went a few years later to Industrial Light and Magic, and Disney then sort of, and Industrial Light and Magic worked a lot on face capture and performance capture and full body capture. And then the movie was pitched again, but this time instead of like an in-house actor, Jon Voight. And so I'm going to go back to that and sort of, we sort of further perfected all this vision and machine learning techniques inside the tool set of Industrial Light and Magic with many, many colleagues here, and did performance capture. This was done with Pirates and the Hulk and many other things, sort of creatures. And then also, I left ILM 6 years ago. But some of the tools went on there, and you probably have seen this, Tarkin, who is a little bit of an uncanny character. So it's actually plays out itself in a great way. He sort of, you were a little bit scared of him. There's a little bit shifty thing, and sort of this was one of the big milestones in digital double recreation by Industrial Light and Magic. And then also earlier, some other techniques. But in 2009, back then, when Jon Voight was cast, and so you might remember Midnight Cowboy, the young version of Jon Voight, and then the old version of Jon Voight, there was still too much difference between the old and the young. Then J.P. Lewis and others went on to New Zealand, to Weta Digital, who was behind then the final release of Gemini Man. And they also worked on Paul Walker. This is Furious 7, where Paul Walker died, and then they had to reproduce a digital double of him. And that was another big milestone in the visual Turing test. And depending on who you talk to, I think the majority right now was convinced this was photorealistic. Also in Gemini Man, people are now convinced when it was released that if you saw it in the movie theater in 4K, that was like a few months before the pandemic started. It was very convincing. And so like also now over the last 1.5 years, many other feature films came out where we sort of passed this visual Turing test. So this is great. But if you do it with the visual effects way, you still have large groups, big armies of visual artists touching it up. It's not automatic. You instrument the capture volumes. This is again my old like office mate Paul DeVevec. He went on to USC and then to Google, and he's now at Netflix. And he built a sequence of light stages. You put people in and you get all the lighting, and then you can do all kinds of sophisticated rendering of the human face and body, and also in Industrial Light and Magic and at Weather and many others. If at all possible, you still put your subjects into this fractal suit, because fractals are very good for visual tracking. There's always some texture to latch on that is sort of unique. But also we had techniques, performance capture techniques that could do whatever you wear. You don't have to have a fractal suit, but still it's very instrumented. And then what happened in parallel, besides the high-end, big armies, lots of movie budget kind of production, and there was also over the last actually 30 years, it started in the early 90s when Photoshop got released, the democratization of media manipulation, you know? And I want to just say media manipulation has a bad word sometimes in certain corners. Media manipulation, 99% of media manipulation is very good. It's used for entertainment, for storytelling, for comedy, for personal artistry, your photos, and so on. And it really kicked off with Photoshop. And sort of a fun fact, when I was working at Industrial Light and Magic, John Knoll is the creative lead. He's one of the executives who runs Industrial Light and Magic Visual Effects Unit. I was reporting to him, and his brother and him, like more his brother Thomas Knoll, back on the East Coast, they were actually building Photoshop and sold it to Adobe. And that was then used also in visual effects, like in Forrest Gump. And so that created a lot of things. And then you've probably experienced the last 10 years, computational photography on your iPhone, on your Pixel phone, on all kinds of Android phones and many, many other platforms. And so meanwhile, I'm still sort of at the personal part, but we're going to go then pretty soon to the rest of the community. But I joined Google in 2015. And we built a team mainly doing visual effects applied to virtual reality, but we also started collaborating with the computational photography group of Yael Preach and Mark Levoy and many others. And then in 2017, there was the big launch of Pixel with like putting in AI to do with a single camera without depth sensors, things that you in theory only can do with like very expensive optics. Sort of the first launch was done together with Yael's team, with Nori Kanazawa and my team, where we retargeted deep learning techniques. He sort of figured out not just to track a pose or track a face, but also get very high quality masking. And then this was sort of the bokeh effect or portrait blur, where you can then build sort of depth of field artificially with deep learning. And that sort of kicked off a lot of other features in Pixel. Just last week, a new version of Pixel got launched and also supported by Photos, another Google product you might have heard about. And their new effects, they're still like this effects of bokeh, but now you have like a year ago already, like the entire light stage of Paul DeVevec in your phone. You can do portrait relighting. You can have HDRR, you can have sky palette transfer where you can change backgrounds. Like you have different kind of modes here. And then just last week, there was also this new feature. Also, again, Nori Kanazawa and others built the magic eraser effect where you just click on a button. Maybe somebody photobombed. I don't have the slides here yet. This just happened, the release. Somebody photobombs and you want to sort of, with a single click, swap that object or that person out and have a really nice photo. Then also, like we do also more advanced research. This is all done by my colleagues. I personally, I'm not involved here, but I'm part of a bigger org that is sort of dealing with all this. Per Carlson and others were leading cinematic memories. That's in photos. That was also launched last year, where you then, like, it picks up your photos and it will do some nice movie effect, similar to Ken Burns, but in sort of 3D. And then also many of you went to ICCV probably. People like Noah Snavely, Anju Kanazawa, and many others showing off more sort of prototype work. Infinite Nature you might have seen, where you sample from YouTube scenes and you can infinitely synthesize things. So synthetic media is out there. We also, in parallel, many years ago, because for virtual reality, we want to do sort of, instead of depth centers and so on, running on a big fat PC, we also run on a Android phone, or not just Pixel, but more like lower end phones, how to capture your face. And this is an older slide from 2018. AR Core, the API launch, there was another democratization of capture tag, and you can do synthetic media try-on classes, and there are many, many new features coming out. Okay, so, and I just want to show this. This was not at ICCV, that was at CVPR a month ago. We also take all these techniques, and another very important, and we're not the only ones, is to do movie dubbing, lip syncing, automatically translating videos from one language to the other, with voice cloning, but also lip changes and so on. And this is very much a prototype.
Hi, and welcome back to Machine Learning Foundations for Google Developers.
Bienvenidos a Fundamentos de Aprendizaje Automático. Soy Lorenz Moroni.
I hope you heard that through my microphone. And of course, there might be a delay, and it's sort of funny to show this, the lip sync, but it's sort of going through two different channels. But this was done by Avisek, Lahiri, and Vivek Quatra, and Christian Frew, and many other collaborators. And it's not a product yet, but we're publishing it already. And so, as I said, we're not the only ones. There are many other people who do lip sync, synthetic media, in academic research, in companies like startups, big companies like NVIDIA, ourselves, Facebook, Apple, many others. It kicked off in the 90s. Then it's sort of at SIGGRAPH, and then I think 2016, 2015 even, no, 2016 more, and 2017, 2018, there were things coming out like from University of Washington of video dubbing that really notched it up with the latest GAN techniques or non-GAN techniques like Justus Thies and many others from Stanford and University of Munich. We're doing this thing called face-to-face, which is actually not deep, but it's always sold as a deep fake. Then it moved on into, instead of lots of training data, you can do one-shot learning. The latest, again from ICCV, actually this came from Stefano's lab, where you can have explicit and implicit representation. And I misrepresent his work mostly, and he can, like, after this talk, tell me what I got wrong. But there's also several companies. One of them is in London, Synthesia. There's this thing called MyHeritage that can just take and it also causes controversy, MyHeritage, where you can just reanimate old family photos. And the CEO of NVIDIA, I think also a month ago, gave his keyword virtually completely artificial using their latest technology. Yes, and then as you know, in 2017, 2018, it was before already, but it sort of got really mainstream. Somebody called DeepFakes at the end of 2017 on Reddit posted an algorithm, very simple algorithm, an autoencoder, not even a variational autoencoder, not a GAN, but simple stuff how to replace a face, and showed it actually on pornography and got banned. I don't know, nobody knows who that person was, but u/deepfakes on Reddit is banned right away. But there is actually a very collegial GitHub community that either builds their own source code or takes the latest papers that were published from academics and puts it in, and every few days or a few weeks, new code comes out and they get compiled. There's also like DeepFakes as a service and many other things. So because of this, now it really went mainstream, and it sort of is the appearance that now everybody in their own dorm room could just download something and play with it. The general press and public got aware of it, and you all know for the last 2 to 3 years, just headlines, it's dangerous, especially here in the US and in the UK and many other areas worldwide. And so it is a concern. I still think most of deepfakes technology is used for very good uses for society, but we also need to care about how to mitigate some of the risks. And but then also we shouldn't like blindly just jump on that bandwagon of the hype, like, oh, deepfake is the end of the world. As soon as media was invented, as soon as the camera was invented, people also figured out how to manipulate media. And probably all of you know this from the history books. Lincoln, they changed his hair. You know, Stalin had a secret government lab that was touching up photos and removing people. Before deepfakes, before the AI revolution, Photoshop was out there. Like even like respectable newspaper like the LA Times or others were sort of prone that somebody photoshopped something around and people didn't notice. So manipulated media has been also a bit weaponized for some time right now, for over 100 years. And so now I want to switch gears a little bit. In general, we call this at Google and other platforms to sort of media integrity efforts. And I want to talk a little bit about how we at Google, we have a lot of internal efforts, but also how we sort of interact with the public and with universities and with nonprofits and many other organizations in that space, and then hone in back into deepfakes and others, CheapFakes and many others. And sort of just as like heads up, what the main point I want to make in this talk is that there is actually a surprising observation. What is causing most of those misinformation versus the other surprising observation, what most of the community, especially academics, are investing in right now in writing papers. And I hope like this talk and many other efforts sort of sheds a little bit more light on it and sort of makes the community shift a little bit and addresses their resources more to other more impactful areas that are desperately needed for AI researchers. But okay, I'll get back to that in a second. So one of the big initiatives at Google is so-called the Google News Initiative. This was kicked off in 2018 with some sizable budgets to support news organizations and also academics and nonprofits and research organizations. And now during the pandemic, there was many more initiatives, especially during COVID misinformation. But in general, the Google News Initiative, it sort of recognizes, and that's very obvious to everybody, the internet sort of democratized the printing press. Everybody can build their own newspapers. Everybody has their own blog. And so, of course, it empowers everybody. But then also, this is just next door from you. Well, not next door, a train ride from you at the Reuters Institute at Oxford, some study. This represents challenges to global trust. And so here we highlighted the trust in media went down to 43% in the UK and 38% in the US. So actually, in the UK, people are trusting media a little bit more than in the US. Korea is the least trustful, and Finland has the highest trust. But this is like a few years old right now, this study. It might shift around, but sort of the point is like we have a trust issue here, you know. And what Google with the Google News Initiative is doing is, Google is building quality journalism products to support it. Working with newsrooms, like one of the things that came out of the Google News Initiative is First Draft. This is Claire Wardle and Joan Donovan and many others, first at Harvard, but also in New York City, are doing a lot of very breakthrough research in misinformation, but also in deepfakes. And then also there's a lot of efforts to improve digital literacy, you know, and various universities and foundations are funded through the Google News Initiative. Now, a more technical, concrete thing is that's not the Google News Initiative solely, but it's sort of like an ecosystem that Google supports and many other people support and platforms is fact-checking. And so there's one thing I want to point out in case you're not in this area. There is a so-called International Fact-Checking Network, Ifcn. It's not run by Google or any platform. It's a nonprofit. And there are fact-checking organizations in the US, in the UK, in India, in Brazil, worldwide. In order to be a member, there are certain procedures. And then there are lots of very interesting work. When are fact checks needed most desperately? When do you have to enhance it? It's like during breaking news. We saw that at the beginning of COVID, there was a lot of misinformation. Well, there's still a lot of misinformation right now, but also when like a hurricane hits, is it category 6, like the minutes and the hours, there's so-called data voids. And it would be good to have fact-checking boosted, and many other things. So this is also like some support by the Google News Initiative and many others. And then there's also another system. It is supported by Google. People at Google are very passionate about it, and it sort of came out of schema.org. Is if you're a fact-checking organization, a fact-checking organization can come in different forms. It's either a publisher or a news company has their own fact-checking department and puts out fact checks. It's a nonprofit. There's Full Fact in London, for example, which is very, very active, and many others. And they have all their own websites and their own format. But then there is this thing called claim review, which is a meta language that's sort of embedded inside those websites. And that makes it possible for Google Search, Google News, YouTube, Bing, Facebook. Like when you search something or you see a YouTube video or on other platforms, certain things, it can automatically parse that fact-checking data set and matches it up and then surf it at the right location on various surfaces. And then I encourage you, if you're interested in this, Google built 2 years ago and constantly updating a fact-checking API and a fact-checking tool where you just can search in the fact-checking data set worldwide. It's not Google's fact-check. Always want to make that point. It's like there's hundreds of organizations that feed in fact-checks, and you can also get a cloud account and go in there and script your latest AI algorithms and figure out how to deal with this fact-check articles. Yeah, so that's sort of very broad misinformation, because this sort of when we moved from synthetic media, from the good uses to mitigation, there is the claim synthetic media can be used for misinformation. And let's go back to deepfakes. And CheapFakes and misleading context and reverse image search. This is all now honing in a little bit into visual misinformation. Visual misinformation is a big chunk of misinformation. We're visual animals. Text has a lot of issues. You can always lie, you can always spread a rumor, but if you back it up with an image or if you back it up with a video, it's even more convincing. And traditionally, we are not fully wired yet to also mistrust an image or video. Even we know Photoshop has been around for 30 years and many other things. But if somebody tells us something, we're more critical and say, yeah, you can make this up. But with pixels, we thought for a long time pixels don't lie, but they lie too. All right, deepfakes. Let's go back to deepfakes. I want to just quickly put it out there. We have lots of internal efforts. Most of my time, and I'm running several teams at Google. We're spending a lot of work internally, but also we are part of Google Research, and Google Research has brain and perception and natural language processing and many other things. We have a long tradition at Google, like Ian Goodfellow was at Google for a long time, working on GAN and adversarial learning. Dirk Kingma, the original inventor for variational autoencoders, is at Google. Many other people are doing active research in NeurIPS and CVPR and ICML and iClear and so on. But then we also built detectors. Some of those detectors, we can talk about this later, like the pros and cons of like actually publishing a detector versus keeping it inside, not to give adversaries the chance of reverse engineering it or adversarial attacking it. And then we also, there's the deepfakes where you can detect if it's fake or real, or what pixels are fake or real. But the more general problem is any picture. Like here is an example of Emma Gonzalez. She was one of the school shooting survivors, and she was, I think it was in Elle magazine or somewhere in a magazine, she was featured of ripping a gun target apart, so for gun regulation. And then somebody photoshopped the US Constitution in it, sort of hinting Second Amendment. And this was used for misinformation, and it went viral. But there's like also, we have collaborators like Luisa Verdoliva at University of Naples and many others who have like state-of-the-art detectors, and they're so-called CheapFakes or Photoshop detectors. And we're also investing a lot of research into this. So public, I know Stefanos, but many others might have seen our data set, and also Facebook and Amazon and Microsoft had data set and competitions. We started also right before the pandemic, released a data set together with leading academics like in Naples, Luisa Verdoliva is a PI, and Matthias Niesner at the University of Munich. They already had a challenge, the face forensics challenge, and it was one of the first data sets where we actually seeking consent from professional actors that it's okay to deepfake them. I just also, I don't go to the details actually there, but sort of, you can now mix and match this data set. There's also the deepfake detection data set that was led by Facebook. It's much larger. All this different data set have different qualities. There's also people, I know there's some people in the audience here, they say, oh yeah, I use this data set, I can have 100% detector on that data set. It was never meant to do this. It was more like add it to face forensics, add it to this, add it to that, further compress it down, use it in together with many other data sets. We have different qualities in there. And here are a few examples of, they're like in the streets of New York. All those people are fake. And we can talk a bit about it, but we're sort of like every year we're releasing another data set. We actually, before the visual data set, we released the fake audio data set, and we're also participating in the speech and language community on challenge problems. Sort of like you might see different companies having different philosophy. Our philosophy is always to let the academics run the competitions, and we're just supporting them with part of the data. You know, we're not running the competitions ourselves. And so this is also an annual competition, the automatic speaker verification spoofing ASV spoof data set, and we continue to support that. And then we also, and I tell it later, there's just a month ago, we supported another challenge at an ACM conference in Istanbul. That's sort of the end of the talk, on something that has been overlooked for a long time. But before I go there, we also do studies. There is actually, I mentioned this before, probably Jigsaw. Jigsaw is another unit at Google that focuses on making lots of different things, including misinformation. And we started out right away when we invested in DeepFakes. We also said, let's assume we have a pretty good deepfake detector in the wild. That's a big question too, with false positives, false negatives. But let's assume we have that under control. What could somebody do with users? And this is not YouTube or anything. This is a generic study. Just a month ago, the results were published. We took Walter Matthau and deepfaked it into Richard Nixon, and then Jigsaw was asking lots of users with different demographics, like had sort of different user interventions, like this video is altered, do you want to watch it, or many other so-called user interventions, and then ask them right after, do you actually believe it or not? Ask them a few weeks later. And even people who have been told this is fake, there's a pretty big percentage who still believe that Nixon received an award and it was really Walter Matthau. And so I put a link up here. This is a Medium article published by Jigsaw that shows more results. And there are many, many other user intervention studies, also Partnership for AI, First Draft, many, many other organizations are working on this. That it's not just a technology problem, it's a much, much bigger problem that we need to solve in this area. All right, another thing I want to quickly say with deepfakes is surprising 3 years ago now, not surprising anymore, is all right, it's there is the threat that you can create a deepfake and then use it for misinformation or cheapfake, but there's also something else called the liar's dividend. And this pops up more and more frequently. And we see it during elections and many other areas. This is one of the earliest occurrences that we tracked. A Brazilian politician, João Doria, right before an election, that was actually 2018 or 2019, 2018, there was a video surfacing of him being in a compromising situation with several women in a hotel room, and they claimed, look, what kind of politician is this? And his supporters right away say, oh, it's a deepfake. It actually is most likely not a deepfake. But because now you can claim that everything is fake and you cannot trust anything, you can call everything fake news or deepfake, and we have many, many other things. And this is sort of the flip side. Sometimes some people even say this, people calling something a deepfake and it's not a deepfake is more harmful than the other way around. And maybe we can talk about that also. In Africa, there was a leader who had a stroke, who was out for a while and then gave a speech. And of course, because after you have a stroke, your facial muscles are behaving differently. So he looked a little bit fake. They called it right away. It's a deep fake, and many, many others. We can talk forever about this. All right, so now this is sort of deepfakes itself. It's important. It's still a lot of people work on it. But then also what we did, and this was last year, is again, we worked with Jigsaw and we worked with several leading academics, starting with Dartmouth, and then there was Hani Farid, who moved to Berkeley, Alyosha Efros's group, and many other, Andrew Owens, Vlad Morario, Abhinav Shrivastava, Larry Davis at Maryland, and Luisa Redoliva at Naples have all these great deepfake detectors, Photoshop detectors. And we at Google AI, together with Jigsaw, pulled it all in and put also an ensemble model and many other ways to show this and have a user interface. Jigsaw was putting in a lot of effort into this. And then through our other collaborations with fact-checking organizations, served it already to fact-checkers. And this is one example. This is also a rule of thumb. Whenever you see a shark in an image, probability is pretty high it's photoshopped, you know. At least that's true for the internet. In the real world, if you see a shark, don't think it's photoshopped, then better run or swim. But on photos nowadays, if you want to sort of exploit priors, most sharks are photoshopped. But all right, so this was surfaced to journalists, and this is now. I also show this to sort of make the point. Those detectors have false positives. They have false negatives. This was a closed, whitelisted experiment to only a few fact-checking organizations. We decided not to open it up to the public. We've seen this actually also with biased dividends. There's some companies who put their API out there, and then you see like there was a deepfake, apparent deepfake, and then the detector false positively said it's a deepfake, but it was not real. Then journalists picked it up and say, oh, this detector said it's false. It must be false. And so the misinformation detectors could cause also secondary misinformation. So in this experiment, at least, we only want to have a closed area and keep them sort of very well trained and understand the underlying technology and always see it with a grain of salt and see it also just as one out of many signals before you take something down. So this is Assembler that we launched last year. Now, the last technology before I do my final point is Provenance. So Provenance, it's not a technology, it's actually a framework, a mindset. Provenance comes from the art world. You want to know where is this Banksy piece of art coming from? You can get the provenance from some office, or you can sort of do forensics provenance and figure out, is this a fake or is this really from the artist? And there are many solutions out there, and we can talk about this later too. Like Adobe just launched a new feature for Photoshop that's built on their content authenticity initiative. The BBC with Microsoft has Project Origin. There's C2PA, which is a big standard organization for provenance. But one thing that has been out there for a really long time, especially for fact checkers, it was not intended for this originally, is so-called Google's image search has a feature so-called reverse image search or search by image. And like in Lens or in other products, you like the users usually, hey, I saw this sneaker. I want to see where can I buy this sneaker or whatever, and it sort of searches the image database. But you can also use it for finding provenance of an image. Like, where does this image really come from? And this is from my colleague Howard Zhu, who was running that team. It's our partner team. And I'm not going through that, but there, if you go to images.google.com or you use this interface here and you upload an image, then you get sort of different categories. You get exact matches of the image, you get near duplicates, which are very important for us, near matches, visual similar, that's sort of more like semantic, and different. And so we're interested in the near matches and the near duplicates. And you can use them to sort of, they're invariant also to some small Photoshop manipulations. And they have been used already by fact checkers. This is a prime example that's actually many years old, like from 2016, where people were claiming this was a demonstration in Turkey. But then if you run that image from that tweet, you actually find out quickly that image is exactly the same that was used in Morocco the year before. You need to do a little bit of mirroring and this and that, and there's a little bit of an arms race going on because people know what are the limitations are. Google has their reverse image search. There's also TinEye, and there is Yandex and many other products out there. But this is a very popular tool by fact checkers to find the origin. Here are a few examples. If you're from the US, there was this big power outage in Texas earlier this year, at the beginning of the year, and they were blaming it on windmills, you know, and say, look, they're all frozen, and here's a helicopter spraying it. But if you run this through some provenance framework, you figure out this was actually a photo from Sweden in 2014. It was not in Texas in 2021. Or memes like everybody's understanding importance of free markets eventually, like shelves, empty shelves. So you think it's coming from a communist regime, but it was actually this, and you can find that with reverse image search. It was in Japan after the earthquake, and you retarget that. And there are also many other examples. There are controversies. Did this athlete really was wearing this t-shirt? If you do a reverse image search, you find the original without it. Fun stuff like you can sort of, if you run the API of the reverse image search, you can have nested an entire tree of provenance. This is the API. Again, I'm advertising Google Cloud Services, and you can have access to all those different things. All right, and there are like several products to make that usable for the general public and for fact checkers. Again, this is like, if you see a shark, it's most likely photoshopped. Okay, I think we want to wrap up in 5 or 10 minutes. I don't see the chat here. I don't see anybody, so I'm just keep running unless somebody tells me stop now. But I only have one more point to make, you know? There is one thing that is non-obvious to all of us. Like, we are like researchers in vision and graphics. We like to change pixels in photoreal, and this is sort of obvious how we create misinformation. But I already showed you some of the examples where you retarget an image without changing any pixel. And this is so-called false context or misattribution. And so if you look here, there are mainly 3 categories of visual misinformation. Deepfakes, or real things, which are not deepfakes, but accused to be a deepfakes, the liar's dividends. Then CheapFakes is not just photoshopping, but it could be also changing the speed, dropping a frame, the famous Nancy Pelosi being drunk. She was not really drunk. Somebody slowed down and then pitch adjusted the audio. Or somebody dropped in a press briefing a frame, and then it looks like a reporter was hitting an intern, but he didn't do that. But the biggest, most prevalent visual misinformation is no pixel was changed. It was just put out of context. And that's not created by AI, but we like to encourage the community that we desperately need AI algorithms to detect it. So again, I'm repeating myself, driving this thing home, but there are like hundreds of papers of deepfake detectors. There are challenges out there. We're guilty of that too. There are prize monies. Let's solve the deepfake detection problem. And there is a lot of abuse there, but nobody addresses like 50%, or like, I don't want to put percentages, but the biggest chunk, nobody knows what to do about it. So maybe it's not sexy enough. We need to make it more sexy to build detectors and other solutions for that. But also, back to Oxford, Reuters Institute, at the beginning of the pandemic, they used claim review, fact-checking articles, and figured out misinformation around COVID. What are the different categories? No deepfakes happened. Deepfakes was not responsible for misinformation, at least back then. The biggest one is the false context or misleading content. That's and manipulation content is only 6%. So we knew this for several years already. You know, we were just sitting on our hands and deepfakes, deepfakes, deepfakes. Let's not do this. But we encouraged. Well, they came up with it themselves, but like Shivanshi Aneja and Matthias Niesner published a paper, an architecture. It's called Cosmos, that uses self-supervised learning, and it trains on lots of positive examples of, like, you know, like if you work on Coco or if you work on many other image tasks, there's an image and a caption. So you sort of can train on that without a lot of misinformation. Then a small part from Snopes articles where this is clearly out of context. So here you see Obama visiting a lab, and here's Fauci, and this is Melinda Gates apparently, but it's not her. I'm not going into that right now, but basically you're gonna see 2 articles on the internet or more. One says Obama and Fauci were visiting Wuhan lab to see the Bat project. The other one says Obama and Fauci were visiting in Maryland in 2014 to learn about the Ebola vaccine, you know? And so doing this with AI, figuring out which one is true and which one is false might be possible, but also might be super dangerous, because, but using AI, using machine learning to figure out, here are 2 articles. They're claiming semantically completely different things. Let's figure out if they're in conflict, you know? And I'm not going into the paper too much, but then that could be sort of alerted, and then fact checkers go in and say, okay, something is fishy here. And that's what we also observe in platforms. Right now, maybe in some future, but right now we don't want to leave it up to the AI to make the final judgment if a certain thing is sort of dangerous for society. We don't want to be an arbiter of truth at the platforms with fully automatic techniques, but we sort of want to have more powerful tools to go through these large amounts of information to know what should be fact-checked, or just alert the user and say, hey, I don't know, something is wrong here, make up your own mind, you know? And so there was a new challenge. The 2021 challenge was CheapFakes, misleading context. It was limited to students at the ACM Multimedia Conference. And now there are more papers out there. I think there are now 4 papers out of misleading context, probably many, many more for the next conference deadline. But I sort of see this here. This is the prevalence and the ignorance. Well, no, let's not call it ignorance. It would be nice if the AI community goes into this much more. All right, I think I made it too obvious what my goal here is. I know this talk is more like overall statements, not known math or anything in it, but I feel like we need to make this statement. And so, again, fake media is not fake news. Most manipulation is innocent for entertainment parody. Malicious intent would be nice if an AI can detect it, but there's also lots of risk if you leave it up to AI to detect if something is false or true. But on the way to make that determination, either with the user or with a fact checker, there's a lot of work to be done with AI tools. I'm not talking about this. We have a few projects coming up, but also besides all AI technology, where we should invest more into, in general, this is the naive slide. This is the last slide. We basically 50,000 years ago or longer ago, we sort of invented this thing called language. We were sitting at the fire, figuring out a rumor and figuring out, and lately some studies are the rumors travel faster than the truth. Nothing new. It's just the new thing is images and video. And then, as I hopefully told you, detectors is not the silver bullet. There is no silver bullet. Provenance is not the silver bullet. Fact checking is not the silver bullet. user intervention is not the silver bullet. Even if we're told with 100% accuracy this is fake, our memory and our belief system might override it. So it is a very complex multidisciplinary effort that is very sexy to address. So I want to leave it up here. And that's basically it. I'm not sure where Stefanos is, but I only see my own slides, you know.
Can you hear me?
Yeah, I can hear you. Should I turn off slide sharing so I can see something, or should I stay like this? Oh, let's stay like this, you know.
Yeah.
So.
First of all, thanks a lot, Chris, for it's very, very interesting talk. I mean, I would like, on top of that, just to comment. I mean, we, as species, we need stories, and we need the stories to be contain. I mean, they may be fictional, they may contain whatever, maybe even deepfakes or whatever. But this is how we, at least the way I view it, is the create. We actually we get values out of them, and we share values to people, and you get values from them. So it's a very, very important thing. So we need stories, and I totally agree with you that deepfakes by themselves are quite innocent. The use of them, in particular the intent of use of something, and I do not know if there are any efforts for the intent of something. Is this intent to create misinformation, or is this intent to make something? And intention is actually something that generally has not been tackled within AI, because I mean the way we create AI is a little bit stupid. So it's nothing about how humans function. There's nothing about human function. Humans do not work with objects. Humans do not work with pixels. Humans work with values and with meaning. So, and this is something totally different. It's outside of the discussion actually right now in regards to AI. And yeah, so we have to think a little bit about what we want our AI to be. Right now, it's all about pixels, and has to change a little bit the direction. It's not easy. It's not easy because our algorithm is not about that.
So I let you finish your, if there's a question, I let you finish, but I have some thoughts about this, you know.
Yeah. Please, because it's very, very interesting to touch upon these things.
Intent has been on the to-do list for AI researchers for the longest, you know. And I remember after 9/11, we were in Washington at funding agencies, and they say, we want to figure out in this surveillance video the intent of that person that is doing maintenance on that plane. You know, DARPA and all the other funding agencies, the usual suspect. And then some performers, some companies says, yes, we can do intent. But some academics said, I don't want to like destroy my career promising you we can intent. And there was a lot of sort of well-intended but destruction of our reputation as a community done, that we can do intent, and 20 years later we still cannot do intent. And so right now for misinformation, intent is also important, you know. And if it's like malicious intent, that's a policy violation for many platforms. You can have a campaign video with some funny stuff in a politician's face, and it's comedy, you know, or you have malicious intent, you know, and that's the difference between a takedown or not a takedown, or a fact check. And so I don't know, maybe you know something that I don't know, but it's still intent half. And then we have bias, we have all kinds of other things we need to, like, it's cultural, it's very complex. It's not a black and white.
Exactly, it's like what humans are about. Exactly. So intent is a very, I mean, first of all, it cannot be very easily put it down into a predefined set of patterns that can be found in, let's say, some videos. It's exactly what are humans about, and this cannot be described very, very. I do not describe, even can be described with patterns. It's something. It's very, very strange, and I mean, I was thinking about it many, many years from now. I do not know how about this kind of very complex, only human has to do with human nature can be described into a kind of algorithm, or can be summarized in kind of patterns. I see this and this and this and this is what it means. It's extremely complex, and it's very contextual, and it's very hard to describe and very hard to be captured by the kind of algorithms we have right now. Needs quite a paradigm shift to go into this kind of direction, and even about what humans are in general and how we can actually get kind of AI that actually can communicate or understand human values, intention, and all these kind of things. But this is a very huge conversation here, and it goes a little bit onto the philosophical side and in ethics and ethical and moral philosophy. I would like to ask you a little bit of some pick your brains a bit about. I have a couple of questions. Actually, two of them I want to ask as well. One is 20 years ago, when actually 15 years ago, I did my undergrad studies. I worked a bit on watermarking before going into computer vision, and a particular part of watermarking is called fragile watermarking. In fragile watermarking, you put an imperceptible pattern, and then if you do manipulation, it breaks, and you can see how it breaks. There are many different algorithms. Do you foresee that? I mean, I do not know if detectors are going to detect. And you pointed out there that it's actually much more dangerous to say that something is fake rather than so picking. And this happens in many different situations, like in face recognition and stuff like that. And if there is a huge, like things are becoming easier and easier to manipulate and will become extremely easy in the next years, do you foresee that there's going to be a centralized agency providing, like, I mean, the only solution I can really see is about watermarking on another one, like blockchain. You can put a signature there as well. What do you think about this kind of technologies?
I actually, my thinking about this changes, and I'm not representing Google's official opinion right now about this, more like me as a researcher. I thought a few years ago, oh my God, if we have provenance, if we can put like sort of the imperceptual watermark in it, and we can figure out some adversarial robustness, blah, blah, blah. I'm not saying blah, 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 but that's great, you know? And then all we have to do is change society, but nowadays I see a lot of like, it's also an arms race. It can be weaponized. It can be, and so let me just tell you, like, there are several efforts out there. So, for example, Microsoft, when they did Project Origin with BBC, they were part of this content authenticity CP2PA, and sort of the global, the overall arching thing is you can use blockchain, you can use all kinds of other cryptographic ledgers and whatever. You don't need to do the heavy blockchain thing, but you say the sort of utopia is I have a camera, I take a picture. There's like secure chips inside my camera. They cryptographically sign it. Then I send this picture out. Maybe my computation photography changes the contrast, or does so it puts like metadata into that. Then maybe it goes onto a social network, or it goes to a publisher. They crop it. They JPEG recompress it. They just put all this metadata in there, and then blah 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 blah, and then it ends up on your own screen, you as a consumer, and it's fully transparent to you where it came from. This came from this reporter, which I trust or don't trust, or this kind of modification was in there, or it might do a direct fact, this has no metadata, you know? So I should not trust it. So there's several problems to that. First of all, most media probably will not, for the foreseen future, have that cryptographic chain, or if you want to use watermarks, will not have that. So what do you do with the rest of it? Second, sometimes in certain regimes, you want to be actually anonymous, you know? It could be even weaponized by some regime and say, okay, you can do watermarks, or you can do blockchain or whatever. I made you now do everything, you know, like that. And so there's actually some weird lately is like, oh yeah, staying anonymous is bad for society. Sometimes it's actually good for society, you know, and we need to think that through more. And so also, like, constantly having these ledgers going with a piece of media might be broken sometimes. If you're a nation state, if you want to, like, there's a great startup, TruePick. They put the GPS location and the timestamp in it, and they have great applications for the insurance industry, or like there were workers, and instead of having sort of like clocking in and clocking out, like when you start working and stop working, you just take a picture of yourself, you know. So there are like certain domains, but if you're a nation state, you can actually scam GPS satellites, and you can think through all that stuff. You can break into a microchip, a sensor off like a phone, and break it. And then with watermarks, I know you've been active in that. And then there, maybe this is a longer argument, but who says with the latest adversarial techniques you cannot break them, you know? Well, you break them and then they're gone, you know, but then you can put another watermark in it. You fake it, you put another watermark in it. I've seen a lot of watermark papers. Oh yeah, we have now a deep technique and we have adversarial learning. And I'm not sure if this is also, the watermarking is a bulletproof technology that cannot be broken. So summary. 3 years ago, I thought it's a much more watertight technology. Nowadays, I've learned so much about it that this could be also not the silver bullet we hoped for, you know, but it might be more solid and might be more proactive than like this reactive detectors with false positives, false negatives, this and that, and detectors usually cannot explain to the general public why do I think it's fake or not, but with watermarks, with provenance frameworks, you can actually explain to the end user. Yes. Yeah. So that's a long-winded answer. Sorry. Yeah.
Yeah. I was thinking about fragile watermarks, which whatever even if you touch it, breaks, and it's very difficult to put that. But it needs a central agency. All of these things require someone to be a central agency, and you trust this agency, and this provides the watermarks. It provides everything. It's not going to. It's not easy to decentralize this unless you have some kind of blockchain, but easy also it's quite difficult on that as well. And so I do not know about that. In any case, I think I'm going to wrap it up here. We had some more questions here, but I don't think we have a lot of time left. It's already 4:10. Thanks a lot, Chris. Thanks a lot, Chris, for
thank you. I hope I can go to London at some point in the future again, you know.
More than welcome to have you here as well.
Yeah.
Cheers, right. Thanks a lot. Thanks a lot.